Welcome to the podcast, everyone. I'm here with Joseph Wei of Technology Ventures Group LLC, and we're here to talk about how hardware is the neglected stepchild of in Silicon Valley. Joseph, thank you for joining the podcast.
Uh, Thank you for inviting me, Eric.
No worries. Joseph, it's kind of funny that the title of this podcast is about hardware and how it's the neglected stepchild of Silicon Valley nowadays, when in fact, hardware was the basis of Silicon Valley in many respects when it first started.
You're absolutely right. I mean, back about 40, 50 years ago, with the starting of the semiconductor company attributed to a company called Fairchild. And Silicon, that's how Silicon Valley is formed. Because I spent 20 years in the Boston area called the 128 Belt, where a lot of computer companies were formed, like Digital Equipment Corporation, also known as DEC, at one point it's the number 2 computer company in the world, Wang Lab, Computer Vision, Prime Computer, Data General, Apollo Computer, which was acquired by HP. So I can name you a dozen of computing companies. So the computing systems actually pretty much were in the Northeast, with the exception of IBM, which is in upstate New York. And a lot of the silicon companies were in the Silicon Valley, with Fairchild, National Semiconductor. Obviously, everybody still know about Intel and many others.
And it's interesting because I feel like even though the history of Silicon Valley is, as you mentioned, silicon, i.e., hardware, the past decade or two has been very much software focused. Software as a service, cryptocurrencies, etc. But we kind of forget that hardware is a critical component to software. Why do you think that is? Why do you think people have so, in the recent past, focused solely on software and completely forgot about hardware?
Couple of things to that. One is a cycle. It's the technology always goes in different cycles. And then the other thing is the capital investment for anything to do with hardware related just costs a lot more than software. And also, I think is the starting the after the dot-com, where we start to have the cloud and also the mobile platform with our smartphones and the tablets. So pretty much Amazon and Google provide all the cloud infrastructure. So remember the days during the dot-com days, right? Back in the 1990s, late 1990s, the dot-com companies still have to raise tens of millions of dollars because at the time we didn't have cloud companies. So the dot-com company got the funding. They have to buy more servers, networking equipment, and host them at data centers. So those are their own equipment that they have to, so that's why dot-com investment is not small. When you look at some of these companies, how much they raise, some of them successful and some of them not successful, because the cloud infrastructure basically took a layer of the investment away from the startup that focusing purely on mobile apps and application and on the software. And even for software, you think about today's software is no longer really software. It's really at the application level. Unlike the the software you're talking about, like the database software, we used to have many database company, but now they all got scooped up by Oracle.
Interesting. I've been reading recently that the likes of Apple and Google, they're now starting to invest in hardware, whether it's their own chips. So with Apple, for instance, it's their M1 chip, moving away from towards more specialized, optimized hardware. Do you think that hardware right now is seeing a renaissance? And if so, why?
Um, Partially is because of Apple. Well, a lot of those companies, IBM, DEC, HP, Sun Microsystem, SGI, they all used to be very vertically integrated, computer companies. So they make their own chips, their own motherboards, and their own operating system. Some of them start to switch to Unix operating system. And then when Microsoft came in the 1980s, and one thing that Microsoft has done along with Intel was to break up that vertical integrated layers and say, hey, you should you should focus on what you do best. As a system company, you're good at service and integration and other type of things. Let other people produce the best chip, because a lot of times, in a way, those vertically integrated systems are very expensive. Starting with the IBM mainframe, which is several millions to tens of millions just to buy one. And that's why, Digital Equipment Corporation, that came out with mini computers, so they can cluster them together, look like a big mainframe. But each mini computer is a tenth or a 20th of the cost of a mainframe. And then the PC-based microcomputers came along and even took that price point even lower. But the thing is, then pretty much the operating system was based on Microsoft, and there were actually a few other like Novell and also SCO for their version of Unix, but pretty much the server side is mainly two. It's Microsoft and also Linux
Hmm.
for server side. On the desktop side, you have a few like Ubuntu, different Linux distribution, but they're not, in the majority is still very much Windows based. And also now with the new wave of the significant growing computing platform is Chromebooks, right?
Hmm.
So it actually takes it one more layer, which is everything is in the cloud. So you don't have any local storage at all, that you don't have to worry about backing up and other type of things.
It's interesting that you bring that up, and I think you kind of hit the nail on the head, is that we've kind of moved into a new phase in terms of, I guess, startup development, because everything's moving into a cloud. So obviously, we've seen a lot of software development in terms of people leveraging cloud services like AWS or Azure from Microsoft, et cetera. Do you think that this will spur more hardware innovation in terms of optimization of the cloud, or how we interact with the cloud from a software and hardware perspective?
Um, Actually, in a way, software and hardware have never really been separated. I mean,
Hmm.
software on pure thin air has to run on some hardware platform, except like I said, if it's cloud-based application, the first big one is Salesforce, right? They take the CRM application on top of the database and then break it out and say, hey, no, you don't have to worry about having your own hardware server running Oracle database. You just pay me for a service, and it's just day one. It has built-in customer relationship management workflow and all the other things, and that creates a lot of startup basically putting the application below stacks. And they just worry
Hmm.
that the customer facing part, and um, also hardware actually, most of the attention of just in general, most of the attention has been focused around consumer based. Once there's a consumer app, a payment app like PayPal or Apple Pay or Visa Pay, or that catches a lot of people's attention. But behind the scene, a lot of application on the hardware side has been IoT hardware has been directed towards industrial automation 4.0. So automation of factories, automation we build stuff. It just didn't get talked about because a lot of these companies, for example, Amazon bought a robotic company called Kiva, Kiva. They do basically, it's a factory robot that picks up a stack of trays of different products to allow a person, whatever order that Amazon customer order. So the person doesn't have to walk through an Amazon warehouse, which some of them huge, it's millions of square foot. So now the parts will come to them. They just have to pick it and put it into the box, and then the robots will take care of repurposing or relocating that inventory to wherever the next person needs to use it. But since Amazon bought Kiva, then Kiva has other basically customer as potential competitors to Amazon. So Amazon basically say, oh, after your contract's over, you are exclusive to Amazon, so you cannot sell to my competitors. So there are like five other companies since with like robots, but again. Getting into that kind of business sometimes is difficult for a startup because the concern from big company perspective is not about technology. It's usually it's the non-technology factors. How much money you have raised? Can you be around in 3 years, 5 years when I scale up with your technology and you have the funding and the infrastructure to support my business? I don't want to pick another vendor after 2 or 3 years. Can you execute? Can this team really execute? Are you reliable? Because can you even take my order, right? My first order might be 10 million, $50 million. Do you have the finances to even accept my orders? So those are type of challenges a lot of times the startup face, and we don't hear about because it's behind the scene. It has nothing really to do with consumers.
It's interesting that you bring up Industry 4.0. I think that's a big factor that, to exactly to your point, we don't necessarily talk about, but we should. I mean, Tesla, they have a GigaPress, and that was kind of an automation that was cost savings related. So, what do you say to those? Well, let me ask the question of, do you think further hardware automation or further hardware development can occur in Silicon Valley, or are we too expensive or too deeply entrenched in terms of software development?
Mm, I think it's difficult to generalize. For example, people say, how can you afford to build a automotive company based in Silicon Valley? It's always in Detroit, right? So
Mhm.
Tesla broke that model because, in a way, Tesla got a couple of good breaks. The $500 million loan from the Obama administration for two tech related company. One is Tesla, one is Solyndra. Unfortunately, Solyndra did not make it, right? But Tesla
Mhm.
grew out to be very successful. If government was an investor, they would have made really well. But unfortunately, that was I think a loan, and Tesla actually paid back early because they didn't really need it once they would get up to a certain milestone. The other thing is that the Fremont plant that Tesla took over used to be called NUMI, which is a joint venture between, I think, General Motors and Toyota. Factory
Yeah.
itself was, so he didn't have to make the investment to build a complete new factory. And also another thing, the skill set is different. I mean, Tesla in a way is kind of a computer on wheels, right? It's no longer
Mhm.
combustion engines that you have to deal with a lot of that. So the mechanics or I don't know what's the right term to call them, because in Germany, a lot of times the BMW workers are not called factory worker. They call like technician or automotive technician, automotive engineers, because they treat those BMW. They're not mass produced, right? So a lot of them have a little bit higher labor skill or the technical skill, to work in those type of environment. And Tesla today, is assembling basically a computer with wheels. So the
Mhm.
skill set is a little bit different, and it's more suitable because we already have a lot of high tech workers here. I think that's another reason why Tesla was able to be successful, starting in Silicon Valley, where labor actually is expensive to begin with.
I think you kind of mentioned a couple of things throughout this conversation where I think you've emphasized the upfront capital cost for hardware development, whether you're a startup or you're an enterprise, and those inherent advantages. And I think with your Tesla example, you kind of hit the nail on the head that a lot of the physical infrastructure was already available to Tesla when it first started at a reduced cost, because GM and Toyota at the time, they didn't need the factory and it already was there and it was already set up for that. Do you think that, well, let me ask two questions. One is, do you think that that capital investment or pre-investment, right? Whether it's physical capital, i.e. a plant, or the skilled workforce, as you kind of mentioned with your BMW example, is a prerequisite for a hardware ecosystem to flourish? That's question one. And question two is, who should be responsible for that? You've kind of mentioned government kind of more or less did help Tesla get off the ground with their loan, or is it a private sector thing? Is the current VC model sufficient, or is it some hybrid that we are currently experimenting with, or is run in certain areas?
Yeah, so those are two very challenging questions. So, uh, I think there are certain parts of the investment. Well, first of all, addressing the high capital costs. Back in the 2007, I think that's when the iPhone first came out. They had 12 apps preloaded on the iPhone. So, for apps. No, so what do people invest in? Basically, um, investor put money into paying for the founder's rent, food, because the founder just basically just crank out codes, right? And then boom, next a game app or some other app becomes $1 million, and then they can go through that Series A and other type. So from an investor standpoint, wow, let's say 5,000 a month for 3 months. That's why I love the accelerated program is 90 days, because in I remember those days. I actually helped I participated in a few hackathons, a weekend hackathons. It was hosted at the PayPal town hall, and within 48 hours, you can have a good working sample of something to show people whether there's potential or not. But that's like back in the early days, like 2007. I mean, most of us still can't figure out what to do with a smartphone, except some people say, well, if I have this app, I can do this and this and that. And it didn't take a lot of capital, and a lot of those investment became thousand more than 1,000x return for the early investors, because literally you have no the founders have no cost except their time, right? So they quit their
Hmm.
job, but they need to live on, right? So you have to feed them, they have to pay for rent. Other than that, cloud, maybe a little bit of cloud services. Most of them have a laptop, a decent laptop, and that's all you take. But especially if you're building a chip, you have to tape out a chip, and most of them at the time is testing out on FPGA, right? Programmable logic. But the thing is, FPGA usually run at a much slower speed. So you can test out the logic, how it works, but in order to get the performance, and if you're very critical in real-time performance, you really have to do what they call a ASIC. And
Hmm.
that's super expensive. And from an investor standpoint, it's like, well, especially nowadays, in the last 20 years, I think we have so many microfunds because the investment in early stage startup has generated a lot of great return for people. So people are willing to take more risk. And the thing is, Silicon Valley is, we have so many companies, so many startup wants to come to Silicon Valley because we have $30 billion a quarter to invest in startup, right? The most amount. And also the ecosystem, right? We have a lot of examples. So I talk about in one of my presentation, coming to Silicon Valley is not just for money, the ecosystem. If you need a chip partner, we have Intel, Qualcomm, Broadcom, Marvell, all these companies nearby who wants to partner with you. Samsung, that's another one, even though a lot of the semiconductors is based out of Austin. So it's the partnership. If you need cloud platform, Google, Salesforce, SAP, even though it's headquartered in Germany, but a big presence here in Silicon Valley. So with a lot of these people. And so the thing is, from an investor standpoint, do I want to put in, $25 million to do a chip for, let's say, 20x return? Or I wanted to
Hmm.
put in $2 million for a software company or an app company, get 25%, 25 times, whatever 20 times return. So the risk reward ratio is roughly the same because especially if you invest, that's why now there are more and more investment getting into the pre-series A, C stage, because
Hmm.
if the startup is very successful and being in scaling, the most amount of return is during that stage, right? Because once you get into Series A, it's a fixed price valuation, price round, and then you go to Series B, Series C, and the formula for calculating valuation is pretty much set. It's based on how fast you grow in revenue and how fast you can break even. So the other part of your question about the overall, I think in the space with whether government involvement. So smart city, I think, is one of those that I think you cannot get around with a private investment period, because laws and regulation have to be set in place. How are you going to control the traffic lights, to optimize the traffic? The traffic data is not owned by a private company; it's owned by the city government, right? So I think the certain type of thing. It's energy is another one, right? So there has to be, for certain type of application, I think it has to be a joint kind of thing between federal, state, or even the city government, along with the private industry that is funding the startups.
Interesting. I think that to your point, I think a hybrid or joint model makes a lot of sense in terms of funding because of the expenses and because of the need for, I think, using your analogy, a traffic cop, right? In order to figure out who owns the data, who needs to do what are the rules of the road, as they would say. I think going back to, I guess, hardware, and I think one of the things I would say is I think there seems to be, at least in Silicon Valley and maybe amongst engineers, a little bit of a perception issue that hardware seems to be lesser than software. And I think you kind of hit the nail on the head, is that even though the returns may be similar, whether it's a hardware startup or a software startup, hardware seems to rank a little lower, at least from a perception perspective. What do you think? Why? Well, two questions again. Why do you think that is, and what can be done to change that perception?
Mm, well, the thing is, I think the newer type of jobs coming out of Google, Facebook, Apple are more related software. So the software
Hmm.
engineer pay range actually has jumped up quite a bit. Now on the hardware, actually, if you are still at analog, yeah, you're specialized in analog, you can still command a very high, pay range because most of the trained in the last 20, 30 years coming out of university are very digital oriented. So analog
Hmm.
is still kind of like a black box. So for example, designing antenna. So there's a company, oh gosh, the name slipped my mind. So they basically memory card with a Wi-Fi built in. They're the first one that you allowed you, because at that time 20 years ago, the digital camera first came out, but they have SD memory. But the thing is, how do you upload oh yeah, pull the SD memory out, stick it into computer, and then you upload. It's like the
Hmm.
MP this iPod, right? So this company came up with the idea, hey, how about if I put a Wi-Fi chip inside SD memory, and then they can just upload through Wi-Fi any picture they took and back it up. But it literally, because there was, I don't know if I actually organized a meeting on behalf of IEEE, or there was one of the meetings I attended. So the founders actually talk about that they had to cut out corners of the SD memory card to allow the signal to come out. And they have to literally try and error because there was no simulation software that allows them to do it. And finally, they figured out how, so digital in a way is a little bit easier because it's either ones or zero. So
Hmm.
where analog, you're talking about a range, right? So very good analog still. For example, right now with 5G antenna. So this in this space, there's still a lot of need for people with that kind of skills, and they are in demand because if you graduate in the last 20 years, most likely you did not get much training in school with that kind of background. So you either learn it from on the job, or somebody who has been in the industry for over 30 years who've been doing the same thing around the analog. Yeah.
It's interesting you bring up the analog because I feel like I 100% agree with you. There's been an extreme focus on the digital side on education and the jobs, but the analog is still something we need. I keep going back to something I was reading about how Mark Zuckerberg of Facebook, he's interested in the metaverse, right? Doing a digital representation of our physical world, right? And when I try and explain this to my partner's relatives, they look at me with dazed eyes and basically tell me, well, I still have to figure out how to pay the bills to fix an actual tire on my car, right?
Mm.
And I think that lack of analog understanding is kind of at our detriment because we still, to your point, as much as we focus on the digital aspect, look, for instance, mobile, right? We still need people to build 5G antennas or whatever the next version will be in order to get that communications, get that instantaneous back and forth. And we aren't really making those investments. Do you think there's an opportunity, whether it's government, private sector, education, et cetera, to like encourage people who maybe have a propensity towards like analog? Because you kind of mentioned analog's a little bit slower because it requires plug and play or trial and error. Do you
Mm.
think there's an opportunity to maybe further people along that path and create a more educated workforce?
I think so. Now the thing is how much demand is in analog chips. So
Hmm.
it's to a lot of things. I think yeah, we have to kind of look at is the entire life cycle of the product, right? So start from the end product, what you're building, a router, a 5G modem. So what's inside, and then you trace it all the way back. Well, what's the most optimized way to build it? That's that's why I think it's great that Apple stick with what they had. They were so Apple used to be called Apple Computer Inc. right?
Hmm.
They,
Yeah.
because of the business on the phone and other stuff overlap, so they changed the brand, so they just call Apple. But they used to be a computer company. They were one of those that they built everything. Now they have their OS, they have their Apple computer hardware, they have their application. There's a company. There are two companies actually quite interesting. One is it's a spreadsheet called Lotus 123 based in Boston.
Hmm.
And they help IBM PC to become very useful, because original IBM came out with DOS, like, okay, I got DOS prompt, what do I do? Like what application? So now with Lotus 123, oh, it's a spreadsheet. You can do financial, you can do modeling, you can do database, because some of the database company hasn't, I think, formed yet. And then there's another company founded by Dan Bricklin and Bob Frankston, who's also on the board of IEEE Consumer Technology Society with me. And they created a software called VisiCal. So VisiCal
Mm.
is for Apple computers. So Apple first came out and said, oh, I want to make a home educational computer for home. So why do you need a spreadsheet? But because a home at the time, I guess, people just didn't think about using spreadsheet, and now we use spreadsheet all the time. But according to Bob, he said basically Apple credited with this physical software to help them to expand into the business world. Because the minute people say, "Oh, I have a mouse, I have a graphical interface," because when
Hmm.
Windows first, now before Windows came out, the PC is not easy to navigate. Apple was very easy because they have a mouse. And people say, oh, I can actually use Apple for my business. Now that I have a spreadsheet, I can keep track of my payroll and all the other stuff. So those two software kind of kicked off, kind of like the iOS and Android kick off the mobile platform, right?
Hmm.
Between Samsung and not Samsung, but Google and Apple.
Hmm. Interesting. Well, I think we're coming up to the end of the podcast, Joseph. So I always like to leave my guests with their final words. So I think we've had a fascinating discussion about hardware. I mean, it's continued innovation, what we need to continue innovating in the hardware ecosystem, particularly in Silicon Valley. But any final thoughts regarding hardware or just in general Silicon Valley? I mean, you've been here such a long time.
Yeah, so now fundamentally, I have an electrical engineering degree. I'm still an engineer at heart. I love electronics, grew up with computers. So anything with a computing engine inside, whether it's a small wearable device or IoT device, I still look at them as a computer. Now the thing is, I think from my years of experience dealing with both the world and also because consumer market is really, I think should start focusing on the end user environment and trace it back what you're building, because the user interface on it's not just software, it's the user interface software on their
Hmm.
software, right? So generally, you can create generic, but I think especially with people with some vision impaired or other type of thing. So you have, I think people can actually focus on end user first, how they plan, how easy is it for them to use a device and translate all the technology backwards. And then hardware will always be some piece of it, because just because it's been not talked about a lot in the most of the media stuff that get the consumer, because most of us in the tech industry, we still get a lot of news. Like IEEE is the largest nonprofit focusing on professional electrical engineering, and they put out a lot of news of latest sensor, latest chip, and all the other stuff. So some of us knew there's still a lot of hardware that's going on. It's just not getting attention from the general consumer side of the, and also from a VC perspective. I think Lux Capital just has always been investing in what they call deep tech. So these are like really high, require high dollar investment to get into. It's not just simple consumer electronic devices. So I think I'm still very optimistic about hardware, and I think the benefit of hardware combining with the right software, and more importantly, is to think about how the user is going to utilize that device at the end to make the user's life a lot easier. I think that would be the kind of secret sauce to drive company to become a successful company. Don't don't want to keep repeating. It's like today, quite frankly, if somebody asks me, it's like, no, yeah, I'm not technical. My grandma or whoever. Now, what do you recommend for a smartphone? I will always say, hey, thing easy to use, and you don't have to have a lot of time to go handheld that. Just just go with the Apple, right? Because the system is designed to be very user friendly, and but it's not flexible, unlike Android, where you can a lot of things, you can do a lot of things that you want if you're technical enough yourself, that you can tailor the Android device to your like. But if you're not in if people who are not technically comfortable with that environment, so I think all companies can look at that model is how to make all these devices simple to use, that non-technical person can use, because a technical person can always be like, oh yeah, this is easy, boom, I got it, right? But for a non-technical person, that and especially medical device, that's why they stop using some of the medical devices or healthcare devices, because it's difficult to use.
I think those are definitely words to live by, which is focus on the end user and their experience. And whether it's software or hardware, it'll sort itself out in the end.
Yeah.
So, Joseph, thank you again for participating on the podcast.
Oh, thank you for inviting me.